Hi guys, this is Mrs. Allison. We are going to extend the idea of all the rational work that we've been doing, from simplifying rational expressions to adding and subtracting rational expressions to now being able to solve rational equations. Before we didn't have any equal signs, but now that we do, let's look at what we can do. We're actually going to go back to one of the rational equations that you have been doing since Algebra 1, really, although we didn't necessarily call it a rational equation at that point, but you have been looking at them. And the example I want to point out to you of the rational equations that you've been doing is something that looks like 3 over x plus 2 equals 2 over 2x minus 4. This is a proportion. This is a fraction equals a fraction, proportion work. We have been doing this kind of solving rational equation for a long time. Now, obviously, it's going to get a little more challenging, but this is a rational equation. So how would I solve it if a fraction equals a fraction? Well, most of the time, when we're dealing with a proportion, we will cross multiply. Well, what does that mean? It means that we take and multiply the denominator of one by the numerator of the other fraction, and vice versa, the numerator of the one by the denominator of the other. The key to solving proportions, the key to solving rational equations like this, is to not forget to distribute. So when I write this, I'm going to be multiplying 3 times 2x minus 4, and that's going to be equal to 2 times x plus 2. Okay, and then it becomes a pretty easy algebra equation that I can go through and solve. So when I distribute, I will get 6x minus 12 equals 2x plus 4. And then I can go through and solve, subtract 2x. I'm going to add 12 at the same time. So we get 4x equals 16, which means x equals 4. Now, the one thing we didn't really talk about in Algebra 1 and maybe even into geometry is what causes a problem with a rational expression or a rational equation. Well, there's a problem if the denominator equals 0. So, one of the things we want to do when we're solving rational equations is we want to check to make sure that our denominator does not equal 0. Okay? Meaning when we get 4, is there any way that 4 could make my denominator 0? Well, looking at this first fraction, if I plug 4 in, I would get 4 plus 2, which is 6. So we're good there. And if I plug in 4 into my second fraction, 2 times 4 is 8, minus 4 is 4. I don't have to worry because that's not 0 either. But it is something we want to be aware of when we're solving rational equations, is what are our excluded values? What are our restrictions on our domain? Okay, well, like I said, not all of our equations are going to be quite as straightforward. And there are two methods to be able to solve these equations. One of them is to get it so that we get one fraction equals one fraction. Okay, so I'll call that method 1, although method 1 from adding and subtracting was a little bit different. Well, it doesn't matter. We'll call this method 1. So it would be getting one fraction equal to one fraction. Get it so that it's a fraction equals a fraction so that we can cross multiply. Okay, so in this example that we have here, this 2 over x equals x minus 1 over 5x minus 1 over x. If I were going to get it to be a fraction equals a fraction, I could either make it so that these two have a common denominator and combine, so that then I can cross multiply, or I happen to notice that in this particular problem, I have a 1 over x here and a 2 over x here, so I'm just going to combine this. I'm going to move this to the other side. So I'm actually just going to add 1 over x to both sides. And since these are like terms, 2 over x and 1 over x, I'm going to add them and I get 3 over x equals x minus 1 over 5x. And then I'm going to cross multiply. So I'm going to multiply x times x minus 1 and 3 times 5x to give me 3 times 5x equals x times x minus 1. So I get 15x equals x squared minus x. I'm going to move my 15 over, so I get 0 equals x squared minus 16x. Factoring, I get x times x minus 16 equals 0, which means x equals 0 or positive 16. Okay. So I see that x equals 0, x equals positive 16. But if I go back to the original equation and I look for my domain restrictions or my excluded values from any of these fractions, what would be one of my excluded values? Hopefully you said 0. 0 is actually an excluded value and therefore does not work as a solution. So my only solution is x equals 16. Okay, so make sure you're checking that it doesn't cause a problem with the domain restriction. Now, method 2 is we are going to find a common denominator. I'm going to say the least common denominator, and we are going to multiply everything. Kind of like method 1 when we were dealing with the complex fraction. So if you watch the previous video and we talk about method 1, it's very similar. So I know my common denominator between x, 5x, and x. My common denominator here, my least common denominator here would be 5x. So watch what I'm going to do. And it's going to look a little bit complicated to begin with, but I'm going to multiply 5x by, that doesn't say x, it says 2 over x, and x minus 1, and 1 over x. And I'm going to take a step that I maybe wouldn't take every time. This would give me 10x over x. Let's do this just so we can see the difference between the two. 10x over x equals 5x times x. You'll see why I'm leaving it like this to begin with. Minus 5x over x. Okay, well that doesn't actually look much easier yet, except I can take 10x over x and reduce it. And what do I get? I get just 10. And I can take 5x times x minus 1 over 5x, and I can reduce this, and I get just x minus 1. And I can take and reduce 5x over x, and I just get minus 5. And so if you look at this, I get 10 equals x minus 6. And when I add my 6 over, I get x equals 16. Notice I don't get the extraneous solution here. I need to check 16 to make sure that it doesn't cause an issue with my domain, but I don't get that extraneous solution. So it's just another method to try solving a rational equation. So you get to choose. Do you want to get it so that it's something like we've been doing since Algebra 1, where it's a proportion and we cross multiply? Or do we want to find the common denominator and just work to get rid of our denominators so we don't have to deal with them? I kind of like not dealing with fractions. So I prefer method 2 in this case, but that's up to you. So let's look at an example. All right, I would love for you to try this example. So hit pause and come back. All right, similar to how we did, and I probably am going to stick with method 2 just because it's my preferred method for myself, but similar to how we added and subtracted rational expressions in the last video, I'm going to do something similar here. So the first thing I'm actually going to do is I'm going to rewrite this equation to look at and see what my common denominator might be, because to find a common denominator is going to make my life a lot easier. And what I notice is that the denominator of this fraction, although we don't ever write it, I'm going to write it now, is 1 over 1. So I have 1. I have a 3 times a 2x plus 1 and a 2x plus 1. So what is my least common denominator? Well, my least common denominator in this problem is 1, I don't need to write that, times 3 times 2x plus 1. So it helps to factor it, even though I'm not going to do anything with the factors at the moment, it helps to factor it to be able to find my common denominator. So now I'm going to take and multiply 3 times 2x plus 1 over 1 times everything that was in this problem. Now I'm going to actually leave it in its factored form. That does not say 3, it says 2x plus 1. Okay, and I'm going to take an extra step again that I maybe wouldn't always take, multiplying, distributing this whole common denominator into every term. I'm going to get 3 times 2x plus 1 equals 3 times 2x plus 1 over 3 times 2x plus 1 plus 3 times 2x plus 1 times x minus 5 over 2x plus 1. And the reason I'm going to do that is because now I can start to cancel things that are alike. So for example, that whole fraction becomes 1. So I have 3 times 2x plus 1 equals 1 plus, and then over here my 2x plus 1's cancel out, so I'm left with 3 times x minus 5. So much easier of an equation for me to solve. So now I'm just going to go through and do the algebra. So 6x plus 3 equals 1 plus 3x minus 15. Combining like terms, I get 6x plus 3, and maybe you'd skip a step or two in here, and that's okay, minus 14. So I get 3x equals negative 17. Well, that didn't work out as nicely as I thought it would. I probably retyped that problem wrong. Darn it. Well, it doesn't matter. Divide by 3. We get x equals negative 17 over 3. And as long as this doesn't make my denominator 0, which it doesn't, it's not an excluded value, so my answer is x equals negative 17 over 3. Okay. Looking at this example, why don't you hit pause and give it a try? Okay. Hopefully the first thing that you did on this problem was to factor the just the bottoms. So I can see what the least common denominator would be. And again, this is if you're using method 2. This one with method 1 would be a bit of a mess, but we could look at it. Okay, so looking at my denominators, I have an x plus 3x minus 3 in this first one. I have an x plus 3 in the second, x minus 3 in the second. So if I figure out my common denominator here, my least common denominator is going to be x plus 3 times x minus 3. And that would encompass all of them. So let's go through and multiply each of the original problems by that common denominator. And I oopsies, I didn't want that. Plus 2 over x plus 3 equals 5 over x minus 3. And I'm going to multiply this. Remember, this is like it's over 1. So here's what this looks like. I would get 4x times x plus 3 times x minus 3. And if you start to see the pattern and you don't want to write this every time, that is fine. Plus 2 times x plus 3 x minus 3 over x plus 3 equals 5 times x plus 3 x minus 3 over x minus 3. Okay, and now I can cancel them. And so canceling the terms that are alike in the tops and the bottoms, I can't go across any of the signs, the addition signs, but from each fraction I can reduce as much as possible. And so I end up with this algebraic equation that says 4x plus 2 times x minus 3 equals 5 times x plus 3. So I get 4x plus 2x minus 6 equals 5x plus 15. 6x minus 6 equals 5x plus 15. And simplifying, I get 1x equals 21. And as long as this answer is not one of the things that would make my denominator 0, then I'm good. All right. So we will see you in the next video.